ARPA-E plays a pivotal role in advancing early-stage energy technologies.
Technology to market activities help us guide our performers in modeling the value of their technology in the market.
At the conclusion of an ARPA-E project, it can be critical for our awardees to commit additional resources to give their technologies a real chance to move out of the lab and into the market.
Eagle Picher is a really exciting company that's based in Joplin, Missouri. With ARPA-E funding, they developed a battery for grid-scale energy storage.
Eagle Picher has been around for over 170 years. And for the last 100 years almost, we've been working on batteries. And it's becoming more and more apparent that our grid and the infrastructure that needs to be replaced, the transmission and distribution problems that we're experiencing, aging generation sources, all of those can be helped by mass storage. And so that's created an opportunity. For grid energy storage, different batteries have different positive attributes. Lithium ion does some things well, lead acid does some things well, sodium nickel chloride does a lot of things well. And so we look at combining the sodium nickel chloride chemistry with other chemistries in a hybrid approach. And so that hybrid approach is what we kind of brought to the table, and bringing sodium nickel chloride in helps our grid energy storage solution immensely. By putting different chemistries together, you can optimize the battery overall and extend its life. And so the total cost of ownership goes down. So by the time the hurdles for market acceptance for large-scale grid energy storage is there, we believe that this technology will be ready to take to market and to build a manufacturing plant around the technology to satisfy those demands. This project has represented a tremendous partnership between ARPA-E, Pacific Northwest National Labs, and Eagle Picher. By being able to leverage ARPA-E funding and PNNL expertise in a partnership fashion, it has moved the project along and it made it much more feasible to do from the start.
For our project teams, the story doesn't end when ARPA-E's initial investment ended. Baldor is an example of an ARPA-E awardee whose internal leadership made the commitment to moving their technology toward the market.
They're getting the motor out there on the shop floor and optimizing its build process today.
Well, the basic concept is to develop the next generation of traction motor without using rare earth materials and have a high performance traction motor at very low cost. Baldor is a motor company that specializes in both general purpose motors as well as custom motors of all types, AC as well as DC. The motor that we've got on test has got 5 different new, very innovative technologies. But one of the really key significant technology development efforts is the way we cool the winding itself using interlaminate cooling. In the past, we've always used a cooling jacket around the motor, and that lends itself to some challenges in terms of getting the heat out of the motor. When you can actually cool the winding itself, you're able to significantly improve the performance of the motor, get the motor down into a smaller package, and by using non-rare earth materials, make it very cost effective. The next phase is to be able to take that same technology and migrate it into some of our more standard commercial and industrial motor products. One thing ARPA-E is very interested in is getting this technology commercialized. So part of our efforts are to work with the automotive manufacturers and make them aware of the advances that we've made.
As they're removing the initial technology risks associated with the motor and the battery, they're also developing the business case for these novel technologies.
This is exciting because we're getting closer and closer to the point where we get to see an actual product being sold to customers that's going to change the way we consume and store energy.